Okay, we're going to talk about factoring. And notice that this first term does not begin with a 1, so we're going to need to use a longer version of it. This longer version works all the time in every problem, even those that begin with the 1. So, but this longer version takes us right to the answer. It's really beautiful. So, the first step of it, and here's all the steps, by the way, if you want to pause your screen and write down each of those steps, here's the steps that we're going to use. It looks like a lot, but each step is very tiny. Each step doesn't have a lot to do in it. It's pretty simple. I've broken it down into some pretty small steps. So, like for step 1, for example, we're going to look at the problem and say, is there anything in common in the whole thing that we can pull out of it? And if we find something in common, we're going to bring it down with the rest where we're going to put our eventual answer. So we're going to come over here, and do we see anything in common? Yeah, there's a 2. All of those can be divided by 2. And so if we pull out that 2, and that's the largest thing, nothing larger fits into all 3 terms. We don't see any letters that are common to all 3 terms. These 2 have Y's, but this one doesn't. So 2 is the only thing that this has in common. So we're going to pull out that 2, and I tend to forget to include it as part of my answer. So I always draw an arrow down, and I write it down here where my eventual answer is going to be if I'm able to pull something out in step 1, because it never fails. I'll get working through the problem, and I'll forget that I did that. And it has to be part of the answer. So now we're only going to look at what's left over. So if we pull the 2 out of there, divide it out is what we're doing. So what we have left is this. And double check yourself. You should be able to use the distributive property and multiply back through and come back to the top to make sure that's what you would have gotten, just to make sure you did it correctly. Okay, so now we're not going to use the 2 anymore other than put it in our answer. We're just going to work with this part. So this is actually the answer to FOIL. Remember we did first, outer, inner, last? This is the answer to FOIL. And we are trying to undo the O and the I part so that we can see what made up that negative 3y, so that we can then do what factor by grouping. But the possibilities, if you use your imagination to figure out what makes negative 3, there's an infinite number of possibilities, and that could be maddening and stressful. So let's not go there. Let's not try and figure it out in our brains. There is a method that we can use that will tell us exactly what the numbers were without having to guess and check and all that. That's crazy. So let's use this process. Here is a process that works. That's why I have them inset here. This is the process we use to find out what the O and the I of FOIL are. So the next step after we did our common thing is step 2 is multiply the first and the last digits, the coefficients. So if you come over to here, the first and the last are here. So we're going to multiply these. And you include the sign. So it's 10 times negative 1. That's the first and the last digits. And so the answer is negative 10. So that's the answer to step 2. That wasn't hard, right? Multiply the first and last. No big deal. The next thing we want to do is list the factors of that number. And I know that in the videos sometimes they show you just list all the possibilities, like negative 5 and positive 2, negative 2. But don't do all that. That hurts our brains. Don't do that. Let's just list the factors of 10 first, just 10. And there's a way I want you to do it that's going to help us, especially when we get to bigger numbers. So be really careful to do the smallest number you can first and put it on the left. So 1 goes into 10, 1 goes into any number. So 1 times 10. Then go to 2. If 2 works, write it down under the 1. 2 times 5. Now, I know right now that I'm done, and I'm going to explain why. When I put down the 1, and I did 1 times 10, That meant the only other numbers I needed to consider were going to come between 1 and 10. So whatever set came next, both numbers would have to be between these two. So when I did the number 2, and I got 2 times 5, interestingly, every set that's next has to come from between 2 and 5. So both numbers would have to be between 2 and 5. So the only numbers that are between 2 and 5 are 3 and 4. Well, 3 doesn't go into 10, and 4 doesn't go into 10. So I'm done. And we'll do some more of that in a little bit with some bigger numbers so you can see how that works. So what we did is we listed the factors of our number. That wasn't too hard. Step 4 is now we have to decide the signs. And it's going to take step 4 and 5 together. It's 2 steps to get the signs right. So the step of getting signs is, sorry, I got a little shadow going on there, is look at the sign of the middle term of your problem and put that sign on the largest number of your factors. So over here, this problem has a negative on the middle term, and so I'm going to put that sign on the largest number in each set. Now, one of the other reasons that I want you to write these in the order that we did is because when we do, the left column is always your smallest number and the right column is always your largest number in each set. And so I don't have to look at each set individually and decide where to put the signs. If this says use this sign, whatever's here. If this is positive, then we'd put positive on the largest. And since this is negative, we're going to put negative on the largest. So I can come over here and I know these are all my largest ones. So I'll just put that sign on there real easy in the list. Now, that was step 4. Get the sign on the largest one correct. Figure that out. Then step 5 says decide the sign for the smallest one. And really, you're just saying, okay, if I multiply the numbers in this set, 1 times negative 10, or negative 1 times negative 10, should this small number be positive or negative? We have to look back at what we're trying to get. We're trying to get a negative 10. We know that the large ones in this case have to be negative. So in order to get a negative 10, these small ones then would have to be positive. So now we know the signs on both of these. Small ones are positive, large ones are negative. Now, step 6 says add each of the sets together and then find the one that equals the middle term. So our middle term was a negative 3. So when I add each of these sets together, the set that equals negative 3 when you add it is 2 and negative 5. And so now we know what the O and the I were. It was a positive 2 and a negative 5. So step 7 says rewrite it as 4 terms. Replace this O and I that was combined here with the numbers that we just found, and those numbers will have the letter that 3 had. So it'd be a 2y and a negative 5y. And it doesn't matter which order you put them in. You could put, we're going to rewrite this, all 4 terms, 10y squared. We can put it as plus 2y minus 5y, or we can put it as minus 5y plus 2y. Either one is totally fine, okay? Whichever way you like to look at it. So I'm going to put plus 2y minus 5y minus 1. So now we have F, O, I, and L, all spread out. So now we're ready to do factor by grouping. And factor by grouping says, don't look at all 4 terms, just look at the 2 on the left and then the 2 on the right. So I call that cutting the problem in half. What I do, I know in the videos they had you put parentheses around them. I don't like that. It always makes me think about multiplication. So I like to just cut it in half like that. And then I ask myself, just like I did up here, do these 2 terms have anything in common with each other? So yeah, they have a 2. They both can be divided by 2. And they both have a y in common. The most they have in common with each other is a 2 and a y. And if you took that out of there and you had to multiply back up and get this and multiply up to get that, what you would have left over then here is a 5y, because 2 times 5 is 10, and y times y is y squared. And then what times 2y gives you 2y? That's a 1. So now we come over to the other side, and actually we could just write this set over here because we always want those to match. But if you don't do that, that's fine. You can still say, like we did over here, what do these two have in common? And whenever you do, like here, this was a positive 2 because this was a positive 10. And this, whatever's here, the first term that you're looking at, if it's negative, you're going to pull out a negative. If it's positive, you're going to pull out a positive. So that's why up here at the beginning, we pulled out a positive 2 because this was a positive 20. If this starts with a negative, you have to pull out a negative. So if we pull out a negative something, these two don't have anything else in common other than we know we have to pull out a negative because the first term is negative. This whole thing doesn't, the only thing it has is a 1. So you could call it a 1 is what they have in common because anything can be divided by 1. So if we do that, remember, if you multiply through, you should land up here. If you multiply through, you should land up there. So that changes the signs basically like that. And they have to match. These parentheses have to match. So that's why I said sometimes it's easier just to go ahead and put the set here and then ask what should be out here. If I had to multiply through here to get to here, oh yeah, that's a negative 1. And I have to multiply from here, positive 1 to get negative 1, it has to be negative 1. Alrighty, so what we just did so far is part of step 8, the grouping. We cut the problem in half and we looked at the left side, and then we looked at the right side. Now we're ready to look at what we've written and look for our two sets that are our answer. So what's common to both sides of the problem is they both have this parenthesis, and that's going to happen every single time. So 100% of the time. It's not even just sometimes. It's going to have the sets have to match, and whatever is not in the sets makes up the next set. It's 2y minus 1. And it really doesn't matter which order you write it in. You could put the 2y minus 1 first, and then the 5y plus 1 second. And the reason that it doesn't matter, it comes down to what we know about the commutative property of multiplication. You had to learn that earlier. But it's the idea that if you had 5 times 3, that's the same as 3 times 5. They're going to always produce the same answer for multiplication like that. So, and that's what you're finding. You're finding a multiplication problem. And so if this times this is the same as this times this. So that's how we do our factoring.